Once again, I've ended up with a hard puzzle where I can't go any further, and I'm going to use this puzzle to show you a couple of extra strategies that are available to us when we get stuck. So the first thing I'm going to do is fill in pencils, and a reminder what this does. It means that every blank square has every possible number put in. Now, one of these strategies I pointed out to you is that we can look for a row or a column or a box where a particular number only occurs once. For example, in this box here, 2 occurs twice, 6 occurs twice, 8 occurs twice. So that doesn't help us very much. And so we can go looking painstakingly. But if you find they're too painstaking, you might like to use the S key, which will find any such singles. So I'm going to press it now, and you'll see that it's found a single here. Now, at first sight, this doesn't look correct because there's 2 8s and there's 2 9s, whether we look at this row or whether we look at this box. But if we look at this column, we can see that although there are 3 8s, there is only 1 9. So my program's got it right, and we can in fact put in a 9 there, which means that we can put in an 8 there. And if we press S again, it doesn't give us anything because there aren't any more singles like that. So now it's time to introduce you to a couple of other strategies. The one I want to show you first is this one here, which is called X-Wing. I'm going to press it and then I'll try and explain what it's all about. The idea here is these pink squares, there's 4 of them, and you'll notice that each of the squares contains a 9. You'll also notice that in this row there are no other 9s, and in this row there are no other 9s. So at the end of the day, a 9 will have to go here or here. If it does go here, then it means that 9 can't go there, so it'll be that 9. Alternatively, if this 9 goes in, then that one won't be a goer, and this one will. So that no matter what happens, we'll either get this 9 and this 9, or this 9 and this 9. In other words, we'll end up with the 9 already taken care of in this column, and also taken care of in this column, which is why down here it says that we can remove 9 from these columns. Not the 9s in the pink ones, of course, any other 9. And if you look, there is in fact a 9 there. And we can now remove that. Now this strategy is called X-Wing because people imagine that these 9s, if you draw a picture connecting them, you get the letter X. I found that it doesn't happen very often that you can find X-Wing, and my daughter thinks it's cheating to provide this button for you here. But my idea is that by using this button and having a look at it, you start to get the idea and learn about it, and then you can try and find them for yourself. Now if I press the X again, it says no X-Wing found because we've already dealt with that 9. So now I can move on to the other wing, that's Y-Wing. And this is quite different. This starts with us finding a cell, or square, whichever you want to call it, that has just 2 numbers in it. Of course there are lots like that. But the one that's found is this one, which has a special property that there is this yellow one here that has a 6 in it, and this yellow one here that has a 7 in it. So in other words, we've got the 7 here and the 6 here, And the very important thing is that the other number in these pairs is the same. Now the argument is very like X-wing. If, remember that these two here, there must be a 7 or a 6 here, because they're the only possibilities for this particular square. So if that ends up being a 7, then that won't be a 7, and it'll be a 2. If that ends up being a 6, then that can't be a 6, and it ends up being a 2. So no matter what happens, whether we get a 7 or a 6, we will end up with a 2 in one of these yellow squares. This means that any square that those yellow squares can see can't contain a 2. And you see there is such a square, this one. So it can't possibly contain a 2, because this is going to end up a 2, or that's going to end up a 2, so the 2's will be taken care of in this box, so we can take that 2 out. Let's have another go with Y-wing and see what happens. Notice it's come up with a different one this time, because we've dealt with the other one. This time it's found a 2 and 7, and it's found a square with a 2, a square with a 7, and these two share the 6. Notice this time they're not in the same box. That doesn't matter, but it's the same idea. Any square that can see both these yellows cannot contain a 6. And you can see there is such a square here. This one here has a 6 in it. So if that ends up being a 6, that can't be a 6. If that ends up being a 6, that can't be a 6. So we can take the 6 out. And immediately that tells us that's a 3. And then that's an 8. And that's a 2, and so on and so on. You can see a 3's popped up here. In fact, this will now take us all the way to the end, and you might like to see my singles auto in action, which you can try at any time, and it will go as far as it can, filling in the singles. So there you go, that's X-wing and Y-wing. Y-wing, by the way, is far more common than X-wing, and you can try those buttons at any time, the X and Y. It'll tell you if there's one or not, and hopefully gradually get to learn how to use it without having to get the computer to help you. We looked earlier at naked pairs, like the two that I'm looking at here. Now I'd like to take it a step further and introduce you to naked triples. And here's an example. You can see it's the same sort of idea, except we're now dealing with 3 rather than 2. But it works exactly the same way, because these 3 squares are going to account for the 1, the 8 and the 9 somehow. That means there can't be another 1, 8 or 9 anywhere in this row. So immediately we can take out that 8, and we can take out that 9, and that means we can put a 7 in. But we can take it a step further. This 9 up here means there can't be a 9 in here, and yet these 3 blue squares are still going to account for 1, 8 and 9. Admittedly the 9 can't go here anymore, but it's going to go there or there. And so, still, we can rule out any 1s, 8s or 9s in this particular row. In particular, we can take out that 1 there. Now you'll also notice that an 8's been revealed here in our work, so I'll put that 8 in. And now you can see that we've got the 3 blue squares, but now we've only got the one of the 3 squares containing all 3 numbers. But it still works exactly the same, because somehow or other the 1, the 8 and the 9 are going to appear in these 3 blue squares. Of course we don't know where, but they still rule out any other 1, 8 or 9 in this particular row. In particular, we can take out that 8 there. And one more example for you. you can see that the 3 pink squares here share a 1, 6 and 9, and so therefore there cannot be another 1, 6 or 9 anywhere in this column, which rules out that 1 or 6, which tells us straight away that it has to be an 8. Now you'll find that these naked triples appear quite frequently. They won't always help, but you should get used to spotting them so that when they do help, you won't miss them. In fact, in my hard puzzles, you'll find that some of them require you to use the naked triples to get right through to the end.